Hi, welcome to the Gloyer-Taylor Laboratories presentation for the Navy STP. I'm Paul Gloyer, president of GTL. When we founded the company in 2005, our focus was on developing transformational technologies that would change the game in the space industry. At the time, the space industry was stuck in a rut and still relying on 1960s and 70s technologies with only minor improvement. So we set out to solve the really hard problems in space, and we succeeded. Our composite cryogenic propellant tanks have been validated to provide 75% mass reduction over the state of the art. With this technology, the cost to access space can be reduced by 20 times compared to current launch cost. At this price point, space travel will be competitive with transcontinental aircraft and allow routine, affordable access to space for everyone. Additionally, our combustion stability software is game-changing for the propulsion system development area. Combustion instability has been the number one technical risk facing the development of new rocket engines and motors, as well as gas turbine combustors and augmenters. The cost overruns, program cancellations, and lost performance caused by combustion instability issues accounts for over half of all of the U.S. Historical rocket development cost. However, our combustion stability software has been validated to provide accurate and reliable predictions of combustion instability in a way that engineers can rapidly use the knowledge to eliminate combustion instability in their designs. GTL has demonstrated this capability by developing and hot fire testing the SSE liquid rocket engine. Not only did we prove the engine has better combustion stability, we also achieved higher performance than comparable engines. Along the way, our research expanded to address other critical problems. We have developed advanced radiation shielding that can actually generate electrical power from particle radiation. And it also provides better radiation shielding per unit mass than conventional approaches. We're developing nanosensors that can survive in extremely hot environments and provide critical flight data for hypersonic vehicles. Our composites technology suite has also expanded to include high-performance compressive structure like we used in the Mk-48 torpedo fuel tank development effort, which we'll discuss more in this presentation. We are also developing toroidal tanks for missile interceptors that include electronics, antennas, and cables, all integrated directly into the composite toroidal propellant tank. One of our most exciting breakthroughs is our composite liquid hydrogen tank technology, which will be mentioned in this presentation. These vacuum-insulated Dewar tanks can carry 10 times more hydrogen than conventional tanks, which will revolutionize the transportation industry by allowing aircraft to fly 2 to 4 times farther or longer than they can on kerosene-based fuels. With these Dewar tanks, aircraft operating costs per cargo mile can be reduced by 50% compared to conventional aircraft, while also eliminating carbon emissions. This provides a rare alignment of environmental, economic, and military interest. Over the last 15 years, we've used the SBIR program to mature and validate this suite of technologies, with many of them now at TRL 5 and 6. Because of this, we're now creating products and systems using these technologies. Some of these include the line replaceable Mk-48 composite fuel tank that has been developed as an upgrade to the current Mk-48 aluminum fuel tanks. We're also developing liquid hydrogen storage and feed systems to retrofit helicopters, airplanes, ships, and trucks. Our heavy lift drone will be an airborne box truck capable of transporting a ton of palletized cargo. Furthermore, since the high performance of this drone allows it to operate for over 24 hours without refueling, it would greatly simplify overwatch logistics. We're continuing the development of our rockets and space vehicles. So we hope you'll take the time to go through our entire presentation and learn how GTL technologies can dramatically help your mission requirements and systems needs. Thank you for listening, and we look forward to meeting with you soon. GTL has been researching cutting-edge technologies for over 15 years. Our focus has been on developing high payoff solutions to critical pain points that have constrained aerospace and marine systems. GTL's ultra-lightweight composite cryotanks provide a 75% mass reduction compared to conventional cryotanks. With these cryotanks, the orbital payload of a space launch system could be doubled. Our composite compressive structures are lightweight, robust alternatives to metal pressure hulls and can be used in torpedoes, enclosures, or submarines. The same technology can be used to create lightweight Dewar shells for vacuum insulation of cryogenic fluids. GTO's composite radiation shielding technology provides superior shielding per unit mass and can even be configured to generate electrical power from particle radiation. GTO is also experienced with propulsion and fluid systems, having developed and tested multiple rocket engines and fluid control and pressurization systems. Along with this, GTO has developed and validated advanced software that accurately predicts combustion and stability in propulsion systems, including rockets, gas turbine combustors, and augmenters. The insight provided by the software allows engineers to rapidly and effectively eliminate combustion stability from their propulsion systems. The objective of this SBR topic is to increase the range of the Mk48 torpedo by upgrading the aluminum fuel tank with a high-performance composite fuel tank. This new composite fuel tank needs to deliver range improvement while also meeting numerous weapon system requirements and not increasing cost. GTL's Mk48 composite fuel tank meets or exceeds all of the Navy's operational requirements and requested improvements. This composite fuel tank will provide the Navy with game-changing performance improvements to counter modern adversaries, while also significantly reducing maintenance and life cycle costs. GTL's solution combines high-performance composites technology with an innovative design to achieve a line-replaceable retrofit for the current Mk48 aluminum fuel tanks. GTL's composite fuel tank greatly improves fuel utilization and significantly increases torpedo range, thereby enhancing combat effectiveness. Furthermore, GTL's innovative manufacturing process and reduced parts count means that the composite fuel tank production cost is equivalent to the aluminum tanks, while the reduced maintenance and longer operational life means the life cycle cost is greatly reduced. GTO's composite fuel tank exceeds all of the Navy's objectives for the fuel tank replacement effort. The composite structure technology provides greater operational depth and more weight reduction, while the innovative design greatly increases usable fuel and fuel utilization to provide a significant increase in torpedo range. Not only is the composite fuel tank insensitive to corrosion, but design features also mitigate corrosion risk to surrounding metal parts and ensure good metal to composite bonding. The robustness of the composite fuel tank means that maintenance and replacement needs are reduced by over 50% compared to the aluminum design. Lastly, GTO's composite fuel tank exceeds all of the operational and environmental capabilities of the current aluminum fuel tank. GTO's composite fuel tank is poised for insertion into the existing Mk48 torpedo procurement to increase capabilities and reduce cost. The Navy can achieve these benefits quicker by accelerating the Phase 2 SBR options and funding profile. GTL's composite technology and innovative design can also be applied to other Navy torpedoes and submarines. Additionally, GTL's technology provides significant advantages for hydrogen-powered aircraft. The Navy can reduce carbon emissions and enhance naval operational capabilities using GTL's hydrogen storage systems. The composite fuel tanks are based on a breakthrough in cryogenic composite technology developed for space launch applications. This validated breakthrough allows GTL's ultra-lightweight composite cryotanks to carry 10 times more hydrogen per unit mass than conventional technology. Combining GTO's composite cryotanks with the high-performance compressive structure technology used in GTO's composite torpedo fuel tanks has allowed GTL to develop ultra-lightweight vacuum-jacketed composite Dewar tanks that provide 10 times more hydrogen fuel than possible with a conventional tank of the same weight. With this capability, drones, helicopters, and aircraft can fly 2 to 4 times longer or farther than possible with kerosene-based fuels. For example, naval drones equipped with GTL's liquid hydrogen composite Dewar tanks could hover for 48 hours without refueling, greatly simplifying operations for persistent Overwatch missions. Alternatively, naval helicopter range and flight times could be extended by 2 to 4 times, allowing naval vessels to maintain greater standoff distances from adversaries. Furthermore, this increased flight range and reduced maintenance cost means that the aircraft operating costs in dollars per cargo mile can be reduced by 25 to 50% compared to aircraft using kerosene-based fuel, while also eliminating carbon emissions. GTL's hydrogen economy products have a strong competitive advantage in the marketplace due to the dramatic reduction in cost and increase in range, while also being environmentally green. Since the composite fuel tank and dewar tank share common technology and manufacturing processes, the commercial success of GTL's hydrogen economy products will result in naval product improvements and reduced costs. GTL's composite fuel tank products address a wide range of Defense Department applications ranging from torpedoes, submarines, and ships, to airplanes, helicopters, and drones, to launch vehicles, rockets, and global point-to-point vehicles, to spacecraft, space drones, and space infrastructure. Just the hydrogen economy portion of the market addressable by these products is in the hundreds of billions of dollars. The transition of GTL's Mk-48 composite fuel tank to the fleet is greatly enhanced by the synergies with GTL's commercial aviation customers from the hydrogen economy. GTL is currently seeking Round A investment that will enhance our manufacturing capabilities for both products. GTL is actively seeking transition advocates to get these products into the hands of Navy warfighters. Please contact us if you'd like more information about how these technologies and products can help you.